Hey all, I'm going to call this talk Further N-to-O Mappings of Lower Dimensional Control Data to Higher Dimensional Synthesizers. And in this talk, I'm going to basically just do a quick review of the neural net synth setup I've got, hopefully giving a better example of it than last time. I've got a nice video with an overhead shot, and then I'm going to talk about one of the more just kind of absurdly large synthesizers that I'm controlling with that setup. So just a reminder of this neural net synthesizer that I've been working on. Basically, the synth itself has, or a single synth setup has 32 different fluid MLP regressors that it'll only be able to access one of them at a time, but it basically has 4 groups of 8. Each group of 8 controls one synth. That synth can have a different construction. Doesn't matter. It can have as many variables to control as necessary. And I'm going to show one with more variables or arguments. And then each synth also has 8 trainings. So a total of 32 are available, and I'm going to show a little improv with the setup where all the sounds are coming from the synths, and there's 2 of them. So in my setup now, there's 2 of these, one of which is controlled by the joystick, and the other of which is controlled by XY pads. And yeah, so 64 different synths available at any time. Usually I'm only playing 1, but sometimes I'll play 2. So here's what it looks like, and this is what you'll see in the video. And you can see NN synth controls. So here's the controls for, so the bottom right red, NN synth 1 double XY controls. So the XY is what's sending the values into the synth. This bar, the bar 4 above it, is the thing that is that's controlling which synth I'm playing, which of the 4. And then this 8 box here controls which of the 8 trainings I'm on. Above here, this one is linked to the synth 1. These sliders will kind of move around while I'm playing synth 1, and so it's the 16 values that are, or the first 16 values that synth 1 is controlling. It can be useful for me to be playing down here in the the XYs and then control one of the sliders, but I don't do that in this video. Then the second synth is being controlled by the joystick, and the purple in the middle are the extra controls. So the joystick has so you can see in the first synth, there's the 4 buttons that switch between the synths. Well, the joystick has 4 buttons. So those are the switches between the synths. And then these 8 buttons here switch between the training for the synth. And I can switch between trigger on off, like mono trigger on off, stay on, or polyphonic, which for the joystick makes sense. Doesn't make as much sense for the XY, but so yeah. So then the synths are also routed, and they can kind of go directly out. They go through like this bottom set of stuff on the left, which is all these, I call them interrupt modules, where the sound, if nothing here is doing anything, then the sound will just go through and it'll come out as the synth that I'm playing. And otherwise I can interrupt the sound with different effects. So there's like a really quick like looper, a longer 8-second loop. I've got a reverb and a kind of variable delay, and it's going through all these things. And then at the top, so the other thing we can route to, so we can route directly out, but I can turn that down and turn up routing to the whole rest of my instrument. So I can basically send the audio of the synths through all of the processes that I would normally use on an instrument. and so I can process them that way, and that gives me access to like granular stuff and longer different delays. And in that case, the synth won't be going out directly. It'll only be being processed, which can also be affected down in the lower right. So another way to look at that is that there are these two NN synths, and then this other feedback synth, which I'll play a little bit in the video. Those go into a router. The audio can either go to all my other processing servers, or it can go out to these interrupt processes. And then that goes out to the speakers. All right, let's watch this video. Cool. So now I'm going to talk about one of the synths that I really like. And the reason I'm going to talk about this one is because I kind of was trying to make a really extreme one. I was trying to make one with a ton of arguments to control. And I think last time I talked about the joystick. So this time I'm going to talk about the XY synths, because I normally play this one with the XY synths. I think it works better that way. So this synth uses an FM7 circuit, so it's basically a DX7 emulator, and the DX7 is an absolutely insane circuit. If you haven't looked into it, it's completely bonkers, and how they came up with anything 1980s musical, I have no idea. Basically, the circuit has 6 oscillators, and those 6 oscillators can be set up in basically any kind of matrix. And the oscillators have control on them of frequency, phase, and amplitude for each. And then each oscillator is given a number that corresponds to the amount of modulation it gets from the other 5 oscillators and itself. So you can modulate each oscillator with all of the oscillators. So there's this those are the controls over the synth in Super Collider. Hopefully that made some sense. I'm going to show it a couple different ways. It's really funky. Here are the 32 original algorithms of the DX7. So this was the 32 different setups that Yamaha came up with. This is really cool, just wacky stuff. How they came up with this, I have no idea, but it's kooky. So you can see, sometimes oscillators are fed into each other, but sometimes they're feeding back in different ways, feeding back with themselves. There's all kinds of routing matrices going on, and that's how they came up with all these sounds. So I'm going to just play the 32 different sounds of the DX7 in a row. Yes. Okay, so here's the circuit that I am using, and I'll just say off the bat that this was inspired by Fredrik Olofsson's work. He did in 2007 using this module. Basically, he found these fixed values for the frequency, multiply, and add. And what I'm doing is I'm using I'm controlling values of oscillators to modulate those values. So I'm only using 3 oscillators, and because I think it would get a little crazy. I'm already using the neural net to control 50 arguments, but I'm only using 3 oscillators because already there's so much potential, and we in fact only hear 2 of them. We don't hear the 3rd oscillator. So each of these oscillators has frequency, phase, and amplitude control that you can control. I'm not messing with the phase, so I don't touch that because I'm going to do phase modulation through the phase modulation array. And I am controlling, so anytime you see this kind of stop sign, diamond, 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 it's a sawtooth wave where I have argument control of the frequency, multiplier, and add of the sawtooth wave. So the diamonds are things that are being controlled by the neural net, and this is just the sawtooth wave. So I'm controlling the frequency of the oscillator with one of these, and the amplitude of the oscillator with one of these. For oscillator 2, same thing. Oscillator 3, same thing. Now the phase modulation array is controlling how much each oscillator modulates the phase of each oscillator. So here's oscillator 1. It has a sawtooth wave that I'm controlling these 3 values on, that's telling it how much feedback of oscillator 1 goes into oscillator 1, how much of oscillator 2 modulates oscillator 1, how much of oscillator 3 modulates oscillator 1, and so on. After that, the sound goes through a filter, which also the network is controlling the frequency, the Q, saturation, mode, and mix. So there's 50 independent arguments that are being controlled by the neural net. This is another way to look at the circuit, which I think it looks more like the DX7 circuit. So the oscillator that we're hearing, and then the LF saws that are controlling frequency and amplitude, going out to this matrix, which has 3 oscillators controlling the different routing to each oscillator. So it's a wacky circuit, and I think that is, as I said last summer with my other synth, I think that is kind of important for this neural net stuff, or at least for me it works really well, is to create a system that is kind of complex beyond comprehension, and then train the neural net on that, because that's when it does something that I couldn't do otherwise. So here's the code of the FM7 saw. So I'm doing some stuff here where it's terse because I basically use these collections to make the collections of oscillator modulations, modulating oscillators. And yeah, it's pretty simple. And just a couple things here. So multiple NN mappings in one interface. So there's 50 different controllable parameters in this synth. And there's just so many different sounds in there. It's also I'm controlling with the 45 of the parameters, I'm controlling oscillators. So the oscillators are moving based on the parameters, which makes it, or they're moving slowly. They're like the frequencies are like around, they're subsonic. So they're like 3 or 1 or less than 1. And yeah, so a 50-dimensional space. So even if each of those 50 has just 100 points, so it's less than MIDI, we have a space with 10 to the 100 points, which is a huge space. So like all of these things, there's these little pockets of glorious sound, and then a lot like wastelands. And sometimes it'll even get stuck in like a weird space, that's kind of fun. And training involves finding one of these little pockets in that giant space and training around it. And I think that's the obvious solution to having, or why I'm having like multiple mappings of each synth, because there's just so much room there for variation, and I want to be able to have variation in the playing. So hopefully you'll see here, I've got my synth. This is the main controller for the synth. I've got the FM7 saw loaded. These are my input controls, multi-ball, 3 and 4, and those are the triggers as well. And then here are the inputs to the synth. So those are all of the different values going into the synth. So these are the inputs, those are the synth vowels. So if I move the sliders around, so it's very slow because it's like very low importance, so I don't care about what it looks like, but you can see that all those sliders are moving. So I think the timbre of this is really nice because it's got a really rich timbre where you can hear the the intermodulation between the two oscillators, and then you can also hear each of the oscillators. So you've got like this big stereo image going on. So that was one setting. I'll just show a couple. That was another one. Here's a second one. I'll just show 2 more. And then 1 more. So yeah, hopefully you can hear the multiple oscillators modulating each other, so you can really hear the sawtooth waves in there modulating the different FM synth modules in different ways. And yeah, and I think that the nice richness of the stereo image is important to this synth in particular.